go.
Thermoregulation is the ability of an organism to keep its body temperature within certain boundaries, even when its surrounding temperature is very different. This process is one aspect of homeostasis, a dynamic state of stability between an animal's internal environment and its external environment. The Komodo dragon is the largest reptile in the world currently. They inhabit the areas around the Indonesian islands of Komodo, Rinca, Flores, Gilimatang, and Padar. Komodo dragons regulate their body temperature through the use of various physiological and behavioral responses to controlling body temperature. Examples of this would be burrowing, basking, and having cold blood. As the Komodo dragon is a varanid, it achieves thermoregulation by basking and absorbing energy from the sun or warm surfaces. Komodo dragons often like to bask in the sun to warm up and increase their metabolism. While basking, the Komodo dragon will lie perpendicular to the direction of the sun to maximize the amount of sunlight falling on its skin. It will also expand its ribcage to increase its surface area and will darken its skin to absorb more heat. When the Komodo dragon is too hot, it will lie parallel to the sun's rays, go into a shady area, open its mouth wide, lighten its skin color, or burrow into cool soil. This in turn will decrease the Komodo dragon's temperature, and as its surroundings have also decreased in temperature. In the case of disruption to the thermoregulatory system, the Komodo dragon displays behavioral adaptations to maintain its temperature in extreme conditions. An unusual feature about the Komodo dragon is that the temperature inside its mouth is almost 6 degrees lower than the rest of its body. To counter this, the Komodo dragon opens its mouth in the time when it basks in the sun, usually in the morning, as 77% of its basking activity is at this period of the day. The method of gullah fluttering or hyoid panting is used only in cases of extreme overheating, in which the mouth is held open and the gullah region of its throat is inflated with air. Air is then expelled in fluttering fashion to cool the Komodo dragon. Komodo dragons dig dens to protect themselves from the heat of the sun. They may also occupy thickets or burrows at night to regulate the temperature. Optimal body temperatures do not differ significantly from most other reptiles, but deep body temperatures tend to remain more uniform than any other reptile in the Komodo dragon. The thermoregulatory system of heat absorption used by the Komodo dragon works in this way. While basking, the heat from the sun heats up the scales on the Komodo dragon. This heat is then transferred to the blood through the circulatory system. This is because the circulatory system is close to the skin, allowing heat to be transferred into the bloodstream through the blood vessels. The heat is then carried around the Komodo dragon in the blood to its organs, increasing its core temperature. The temperature of the Komodo dragon increases as its core temperature is raised. The enzyme activity within is accelerated as a result. Because of the increase in enzyme activity, oxygen and energy usage levels increase. This in turn causes the metabolic rate to increase, making the Komodo dragon more active during the rest of the day. When the Komodo dragon is almost active enough to go about its daily activity, it will lie parallel to the sunlight to decrease its surface area receiving sunlight and absorbing heat. The Komodo dragon's body temperature must not exceed 42 degrees Celsius or 108 degrees Fahrenheit. When it's too hot, they must rest and seek shade to prevent their body from overheating. The Komodo dragon is most active from 6 to 10 a.m. in the morning and again from 3 to 5 p.m. in the afternoon. During the rainy season, Komodo dragons stay in burrows if they are too cold. The reason for the active period the Komodo dragon is displayed is because the Komodo dragon is an ectothermic animal, meaning that it has cold blood and no internal and temperature control. Because they have cold blood, there is no internal system to regulate body temperature, so it must rely on solar energy or sunlight for its heat. This in turn means that it must bask for long enough so that the sun raises its metabolism by heating up the Komodo dragon. Once the Komodo dragon has basked in the morning, it has sufficient energy to be active in the afternoon. Once the temperature starts to drop in the evening, the Komodo dragon's metabolism drops due to the change in temperature, meaning that it must reduce its activity to conserve energy. Warm-blooded animals such as humans, other mammals, and birds have internal mechanisms that maintain their body temperature within a certain range, regardless of the ambient temperature. This self-regulation requires vast amounts of energy that is obtained through frequent meals. A cold-blooded animal doesn't need to eat as often and may eat a meal once every few weeks. As a result, the Komodo dragon is able to thrive in remote areas which it lives, where food is too scarce for warm-blooded animals. In conclusion, the Komodo dragon utilizes both behavioral and physiological adaptations to maintain its own thermoregulation. Its behavioral adaptations include basking in the sun to heat itself, burrowing into the ground or moving into the shade to protect itself from the sun, and opening its mouth in the sunlight to heat itself. Its physiological adaptation of having cold blood is essential to the environment it lives in, as cold blood allows the Komodo dragon to survive in isolated areas with a scarcity of food, as it does not need to feed often.
Some of the harshest environments in the world are deserts. The Sahara Desert is one environment that is so harsh that even demographically, it is one of the most uninhabited human environments in the world. This goes to show that any organism living in these areas of the earth must be able to cope with the consequences of living there. The Sahara Desert in Africa, the world's hottest desert, has daytime temperatures at a record high of 58 degrees. Having to cope with such extreme temperatures in its average 6-year life, one wonders how the Gerboa, one of the 10 smallest mammals on Earth, survives in this extreme heat. It does this through thermoregulation. Thermoregulation is defined as one's ability to maintain its body temperature within certain survival limits, even if the temperature outside of the body is very different. An example of this for us humans can be seen almost every winter when we start to shiver when our bodies get too cold. For Gerboas, living in environments can be very hot for lengthy periods of time. The Gerboa uses thermoregulation to keep their body temperature from being too hot to survive. What exactly is a Gerboa? They are unusual looking mammal creatures. The head and body are roughly similar in appearance to those of a mouse and range from 3 centimeters to 15 in length, depending on species. The tail is larger than the head and body, ranging from 6 to 23 centimeters. It is used for balance when the Gerboa is on the move and as a prop when the animal is sitting upright. In some species, the ears are small and mouse-like, while in others, the ears are long and rabbit-like. The most unusual things about the Gerboa are its hind legs, which tend to be around 4 times as long as the forelimbs. So for our standards, they are like mini kangaroos that can have massive ears in proportion to their mouse-like bodies. Gerboas sense the temperature change through thermosensitive neural tissue. This consists of receptors in the outside layers which detect the temperature of the skin. Temperature changes in certain sites trigger behavioral thermoregulatory responses. Under ordinary environmental conditions, the body is quick to perceive temperature changes and triggers a response that tells the body, for example, to move to a cooler environment. As this is neural tissue, signals are sent to the brain of the Gerboa, which alerts the organism to behave accordingly. Gerboas have no physiological mechanism of thermoregulation, and therefore rely completely on behavioral responses. Thermoregulation in Gerboas is achieved mainly through use of the organism's behavioral adaptations in environments extreme temperatures. The Gerboa's body temperature is maintained at around 37 to 38 degrees Celsius. One of these adaptations is burrowing. In the extreme heat of the Sahara, burrowing has been found very useful by Gerboas. They will dig burrows averaging 3 meters deep, and when the temperature approaches their harshest, the Gerboa will plug the entrance into the burrow, preventing any extreme heat temperatures to breach. In the plugged burrow, the temperatures will soon approach the relatively neutral temperatures of the soil beneath the surface, giving the Gerboa a comfortable environment and temperature to live in. Also, when away from its burrow and the Gerboa finds itself in a heated situation, it will, much like Australian kangaroos, enjoy a moment to bathe itself in the sand by digging just a few inches through the extremely hot surface temperatures of the sand into the soil where the temperatures can be much more cooler. There it will roll around and lay in the cool sand until its body temperature has been regulated. Also, thermoregulation is achieved among Gerboas as Gerboas are nocturnal, meaning that they are most active at night. This is a key role for thermoregulation, as especially in the extremely hot desert of Sahara, they avoid the extreme daytime highs and are rather active when the temperatures are much cooler at night.